Is it all set? Can I go ahead and start?
Yeah.
2,400. So obviously any number between 2020 and 2,400 has first digit equal to 2. So it's going to be a 4-digit number with first digit equal to 2. Now, since the digits have to be in increasing order, this number has to be either 3, 4, 5, 6, 7, 8, or 9, because 1 and 2 will not work because it's not in, or 0 or 1. 0, 1, or 2 will not work because it's not in increasing order. But we see that if we ever put 4 or higher, then the number will be more than 2,400. So for example, if you were to put 5, then you have 2,500 something. So that's too big. So that actually means that this number must be 3. All right, so now we know the first 2 digits of the number. They must be 2 and 3. Now for the final digits, we see that there's a bunch of possibilities. We can have this either be 4, 5, 6, 7, 8, or 9. And then we're just going to do casework based on which one it is. So for example, if it goes 4, so in that case, we have 2, 3, 4, then my next digit can be anything between 5, 6, 7, 8, or 9. If I start 2, 3, 5, then it can be anything between 6, 7, 8, and 9. If I start 2, 3, 6, it can be anything between 7, 8, and 9. If I start 2, 3, 7, it can be 8 or 9. And if I start 2, 3, 8, the only possibility is 9. So if we just count, I have 5 possibilities here. Maybe 5 possibilities here, 4 here, 1 here. Then the answer is 5 plus 4 plus 3 plus 2 plus 1, which we can see is 15. C. All right.
Do you have any questions on that?
I think there is one, at least, or more. Can you explain why the second digit cannot be 4?
All right, that's a good question. So I assume you understand why it can't be 5 or higher, because then you have at least 2,500. But if it's 4, so let's maybe I'll do that right here. If it's 4, then my next digit must be at least 5. But now I'm already at least 2,450, which is too big because it has to be less than 2,400. So that's why if I start with a 4, then I must be at least 2,450 because the next digit has to be at least 5, which is too big.
Okay. I think that's mainly it. You can probably leave the problem up for a few more seconds.
Yeah, of course.
And some of the questions are being answered by, I mean, they realize after they put it in, okay,
Sure,
I got it
sure.
now, or others are answering it.
Yeah.
Okay, I think we can move on to the next question.
All right.
All right, so we are on problem number 8. So problem number 8 states that Ricardo has 2,020 coins, and some of which are pennies, which are 1-cent coins, and the rest are nickels, which are 5-cent coins. The problem states that he has at least 1 penny and at least 1 nickel. And then the problem asks, what is the difference in cents between the greatest possible and least possible amounts of money that he can have? Let's start with the greatest possible amount of money he can have. So this is the greatest possible amount of money he can have. To satisfy the conditions of the problem, we know he needs to have at least 1 penny. So we're going to have 1 penny multiplied by the monetary value of 1 cent. And then in order to make this the greatest possible amount of money it can be, the rest need to be 5-cent coins. So we're going to add 2019 5-cent coins. Now I'm going to do the math down here. 2019 times 5. 2019 times 5 gives us 10,095, plus 1 gives us 10,096. So he has the greatest possible amount of money he can have is 10,096 cents. Now let's look at another scenario, the least possible amount of money he can have. Well, in order to satisfy the conditions of the problem, he needs to have at least 1 nickel. So we're going to make him have 1 nickel times the monetary value of 5 cents. And then in order to keep this amount really low, every other coin is going to be a penny. So we're going to add 2019 pennies. This gives us 2019 plus 5, which is 2,024 cents total. But we need to go back to the problem and see what they're asking, which is we need the difference in cents between the greatest possible and the least possible. So the difference between 10,096 and 2,024 is 8,072, which gives us answer choice C. Do we have any questions on that one?
Yes, just give me a second. There are a couple of questions. What does the X with the line in the middle mean?
That is a multiplication symbol, so it's just multiplication can also be written like this.
Okay. Okay, I think that's it.
Okay, problem 9.
All right, I'll take this one. So the question is, there's a Akash's birthday cake is in a shape of 4x4x4 cube, and there's icing on all the sides except for one. So how many of the pieces have icing on exactly 2 of the sides? So let's just think about it. Let's say there was icing on all 6 sides of the cube. Then with the cubes which would have 2 sides with icing would be these ones along the edges, but which are not corners. So like these ones right here. They would have the 2 faces that are exposed having icing on them. So if all the sides had icing, then the number of cubes would be there's the number of edges. There's 4 on the top. So 4 times 2. There's 4 on the sides, and then there's 4 on the bottom. So if all faces had icing, then we would have 2 times 4 times 3, which is 24 cubes with icing. But now the bottom face does not have any icing on it. So actually this removes these 8. So these 2 would now do not have 2 faces of icing on them. Similarly, these 2 on the side, these 2 on the side, and all around those 8. So 24 minus 8, 16 have 2 faces, but now these corners actually also have 2 faces exposed with icing on them, because they used to have 3, but now the bottom face is removed. So now they have 2. So we have to add back in the 4 corners. So 16 plus 4 is 20. The total number is 20. And if you don't want to think about subtracting, then another way to think about it is that the faces which have two icing exposed are these ones around the sides. So and then around the 4 sides. So that's 3 times 4, and then also these on the top. So that would be plus 2 times 4, which is also 20. So in both, if you reason it both ways, you get 20.
I think there are questions on this. So there is common question is, why are we multiplying the 2, 4, and 3?
The reason we're multiplying 2, 4, and 3 is if all the faces had icing, then in each of the, so if you think about like these blocks, 1 by 4 by 1 blocks right here, then the edges, the 2 ones in the middle, have 2 faces of icing on them. So that's 2. And then you have to multiply by the number of, on each face, there's, so like basically the number of edges that we would have of this type, there's 4 around the top, there's 4 on the sides, so here, 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 and back there, and then there's also 4 on the bottom. So that's a total of 12, because there's 4, and then because there's 4, there's 3 possible dimensions, and then each of them has 4 around. So the reason is that you have 2 times 4 times 3, which is 24. It's basically the number of edges in the cube times 2, because each edge of the cube has 2 of these faces in the middle, which has 2 icings. So this problem is a little hard to visualize because it's 3D, but if you sort of think about it, instead of drawing in terms of 2D too much, you can see that there's 12 edges of the cube, and each of them has 2 faces which have 2 exposed icings, two exposed faces with icing on them. So it's 12 times 2, which is 24, and then you do the subtraction and addition like I said. Does that clear it up?
Okay, let's move on.
Sorry, I think there is one more, if I can bring up that. It's just, why did we add 4? I think that was the question.
So this was actually a common mistake on this question. The adding 4 is the trickiest part of this problem. The reason is that when you remove the bottom face of icing, then the 4 corners actually, instead of having 3 exposed faces of icing, have 2 exposed faces of icing. So we have to add them in. So it would be 16 plus the 4 bottom corners.
Okay. Yes.
Okay. Trisha?
Okay. This is problem 10. Zara has a collection of 4 marbles, an Aggie, a bumblebee, a steely, and a tiger. She wants to display them in a row on a shelf, but does not want to put steely and tiger next to one another. In how many ways can she do this? So the first thing that came to my mind when I read this problem was, I was like, wait, it might be easier to count the ways that steely and tiger are next to one another and subtract it from the total ways that there are to display all of the marbles in the shelf. So this is a method called complementary counting, which is basically saying count the ways that you don't want it to happen and subtract it from the total ways there are, and you'll get the number of ways that you want to happen. So how I calculated this was that I made steely and tiger into 1 unit, because we are counting the ways that they are next to one another. And then I made Aggie and bumblebee 2 separate units. So the number of ways to arrange these 3 marble units is 3 factorial, or 3 times 2 times 1, because there are 3 spaces and there's 3 ways to put a marble here, and then once a marble is put here, there are 2 more marbles to put here, and then there's 1 marble here. So that's 6 ways. But when we look at this, like, what if we put steely and tiger here and then Aggie and bumblebee here? This does not account, this count does not account for if we have Tiger and Steely this way. So we have to multiply this by 2 to get the total number of ways that Steely and Tiger are next to each other. Now we need to subtract it from the total number of ways. And the total number of ways is just counting each of these as a separate unit. And it's just 4 factorial. Factorials are denoted like this, and it's equal to 4 times 3 times 2 times 1, and that is equal to 24. So we have to subtract 12 from 24, and we actually get 12 ways, which is kind of funny because they're the same number of ways for either one, and so the answer is C, which is 12. Any questions?
Yes, there's one question which can you repeat what complementary counting is?
Okay, so complementary counting is when you count the number of ways that you actually don't want it to happen. And then you subtract it from the total number of ways that it can possibly happen. And you basically get the number of ways that you want it to happen. We use this when it's really hard to count, or like you don't want to count the number of ways that it can happen. There are probably like more cases or something. And in this situation, there was only one way to count these 3 units. So it was much easier to use it in this case. Does that clear it up?
I think there is a question on why do we need to multiply 6 by 2?
Yeah, that's a good question because sometimes I even forget to leave that out too. So basically when I found the 6, let's say that I had Steely and Tiger here, Aggie and Bumblebee here, and then there's another way where we have Steely and Tiger here and Aggie and Bumblebee on the 2 sides, and it just goes on and on for 6 ways. But the thing that we don't count in this is that since Steely and Tiger are different from one another, you can basically, you're kind of forgetting that we can have an arrangement where it's like this. Because this is definitely different from the first one, right? So the thing is that we have to multiply each and every one of these scenarios, which there are 6 in total, by 2 because like each and every one has a counterpart where it's like Tiger and Steely are switched.
Okay, I don't see any other questions. Can we move on?
Okay.
Problem 11.
Yeah. So after school, Maya and Naomi head to the beach, which is 6 miles away. Maya decides to bike while Naomi decides to take the bus. Good job, Maya, for biking. The graph shows that both of their journeys indicating time and distance traveled. What is the difference in miles per hour between Naomi's and Maya's average speeds? So at first the graph looks really scary, but it doesn't matter, and I'll show you why. Let's find Naomi's average speed first, right? So how far does Naomi travel? She travels 6 miles, and she does it in 10 minutes. That's why we need this graph. She does it in 10 minutes. 10 minutes. So we want it in miles per hour, right? So if we multiply this by 6, we get 60 minutes, which is 1 hour. If we multiply this by 6, since we multiplied this quantity by 6, we have to multiply this quantity by 6. So we get 36 miles per hour. Now Maya is biking. Maya also does the same 6 miles, but she takes 30 minutes to get there because she's biking and being healthy. So, we need 1 hour here, so 60 minutes. Again, we'll multiply this by 2, so we have 60. Because we multiplied this by 2, we have to multiply this by 2 to get 12 miles per hour. Do they want to know the difference between the 2 miles per hour? So 36 minus 12 is 24 miles per hour. Any questions?
I think there was a question on why did you multiply by 6, right? I think, can we explain one more time?
Yeah, sure. Okay, so the reason why we multiply by 6 is so we can convert it to hours, and I can actually show you that dimensional analysis over here. So right now we know Naomi travels 6 miles in 10 minutes, but we want it in hours. So in order to cancel the minutes, we can multiply by 60 minutes over 1 hour. If you do this, cancel this out, you end up multiplying the 2 6s to get 6 miles over 1 hour. It's just a faster way to do dimensional analysis, which is just a fancy term for unit conversion.
Any other questions, Supriya?
No, those were the main questions.
Yeah, that's good. More.
Move on.
Yeah. Problem 12, Gopal?
Yep. All right, so this problem is about factorials. So they've given an example of factorials in the problem. So we'll be working with these for the solution. Okay. So yeah, let's solve it. So we have 5 factorial times 9 factorial equals 12 times n factorial. So there's one possible way to do this question, which is to see that you can just divide the left-hand side by 12, and then you can sort of find which factorial is equal to that. But multiplying all these numbers out is going to take a long time, and it's too much work. So there's actually a faster way we can solve this problem. And the way to solve this problem faster is to see that, okay, let's just expand out 5 factorial, because we don't have to multiply 5 numbers. 9 factorial, we have to multiply 9 numbers. So 5 factorial is 5 times 4 times 3 times 2 times 1. And we can do this. This product is 20. This product is 6. And 6 times 20 is 120. This is 120. So then if we rewrite our equation, we get 120 times 9 factorial equals 12 times n factorial. So this is actually really nice, because now both sides have like a factor of 12. And if we divide by 12 on both sides, then we get that 10 times 9 factorial equals n factorial. And then we have the really nice thing that 10 times 9 factorial is actually just equal to 10 factorial, because this is the 9 times 8 all the way up to 1. And if you just add on a 10, then it's 10 times 9 times 8 all the way up to 1. So then we have 10 factorial equals n factorial, so n equals 10. And a little bit hard for me to circle the 10, but yeah, this 10. All right, and I just want to mention one other quick way to do this question, which is to notice that if you are to use any of choices B, C, D, or E, then you have that when you write out n factorial, you'll eventually write down the number 11 somewhere in your product. For 11, you'll write down 11 times 10 something. For 12, you'll do 12 times 11, so on. So basically, if you do any of B to E, then this side will have an 11. And 11 is a prime number. So if you just have an 11 in the prime factorization of the right side, it has to be on the left side too. But if you do 5 times 4 times 3 times 2 times 1, there's no 11. Similarly, 9 times 8 times 7, all the way down, there's no 11. So actually, none of B to E can even work because of that 11. and then that means that the only possible choice is A. So you don't even have to like check that A works. You can obviously do that like how I just showed you, but if you use that trick, you can eliminate B to E, and then only A is left. Okay. Any questions on this one?
I think there is a question on this. 10 into 9 factorial is n factorial. Please explain. I think.
Sure.
Yeah.
Sure. Yeah, I'll explain that. So let's look at 10 times 9 factorial. Let's write out what 9 factorial means. This means that it's 10 times 9 times 8 times 7. But hey, what is this? I just wrote down 10 times 9 factorial. And I just wrote, and this is just 10 factorial, just by the definition of factorial. So that's why. Does this visually make more sense now?
I think there was some question. Yeah. Can you go over the elimination of B to E one more time?
Sure, absolutely. So let's just say for sake of example, let's say we were to pick C. I'll put it in red so it's the wrong answer. So let's say we were to pick C. This is wrong, but let's say we pick it anyways. Then so I'll go to the next page, if that's okay. And let's say we picked n equals 12 is our answer. Then if you write this out, you get 5 times 4 times 3 times 2 times 1. Equals 12. Now times, we'll have some 12, and now we'll have the 11. And my point is that this product on the right hand side has this number 11 in the product, and 11 is a prime number, so you can't factor 11 anymore, which means that the number on the right hand side has 11 in its prime factorization. But let's look at the numbers on the right. Oh, sorry, the number on the right has 11 in its prime factorization. And if you look at the numbers on the left, well, when I multiply 5, 4, 3, 2, and 1, I never get the prime 11. When I multiply 9 to 1, again, I never hit the prime 11. So therefore, these two numbers are equal, so they have the same prime factorization, but we're seeing that the right side has 11 in its prime factorization, and the left side does not. So that can't be. And if we go back to the page 3, then we see that the same thing will happen if we use any of B, C, D, or E. Because when we write out their factorial, we'll always get that factor of 11. Oh, excuse me. When we write out 10 factorial, we miss the 11 because we go 10 times 9 times 8, so on. Does that answer the question?
That's great. Any other questions? Oh.
I think this question is just a follow-up saying, is this rule apply only when you work with number 11?
Well, this rule applies whenever you have a prime number. So let me maybe do an example on the page 4. So the same rule will work with, say, 7. But let's take a really simple example. Let's take 2. So if I have a product of numbers on the left, let's say I write 13 times 17 times 9 times 15 times 2. And then I said this is equal to maybe 11 times 19 times 23. Can this equation be true? Well, it cannot be because, sorry, the left-hand side has 2. So the left-hand side is divisible by 2. The right-hand side is not. So, and then similarly, we can even do this, for this specific example, we can disprove it using 11 as well. This right side is divisible by 11, but the left side is not. And this works because 11 is prime and because 2 is a prime number. So if you don't know what a prime number is, I encourage you to look it up and on Wikipedia or something and read about it. But Basically, the idea is for prime numbers, they can't be split anymore. And there's this thing called the prime factorization of a number. And if you have two equal numbers, then they must have the same prime factorization. So, but to answer your question specifically, this rule works for any prime number.
Okay, that's good.
Yep, that's it.
Yep.
Okay, so we are on problem 13, just rounding the halfway point for our AMC paper. So problem 13 reads, Jamal has a drawer containing 6 green socks, 18 purple socks, and 12 orange socks. Lots of different colored socks in this drawer. After adding more purple socks, Jamal noticed that there is now a 60% chance that a sock randomly selected from the drawer is purple. How many purple socks did Jamal add? So since the problem is asking for the number of purple socks he added, let's assign a variable to that. So let's say X is the number of purple socks added to the drawer. So this means that according to the problem, after he adds this X number of purple socks, the total number of purple socks, there's a 60% that he will choose a purple sock from this drawer. So this means that 18 purple socks plus X purple socks, which gives us the total number of purple socks, divided by the total number of purple socks in the drawer, the total number of socks in the drawer, sorry. So that is 36 plus X should equal 0.6 or 60%. So in short, this equation is saying that the total number of purple socks here divided by the total number of socks in the drawer should equal 60%. Now, when we further simplify this equation, we can multiply both sides by 36 plus X. 36 plus X, I can squeeze that in there. And when we further simplify, we get 18 plus X equals, I will do the math on the side here. So we get 18 plus X equals 21.6 plus 0.6X. Now, when we further simplify using our algebra skills, we can get 0.4X equals 3.6. Further solving for X, dividing each side by 0.4, we get a final answer of X equals 9. So this means that Jamal has now added 9 purple socks to the drawer, which is answer choice B. Do we have any questions for that one?
Okay, I think we're good. We'll go to the next one, 14.
Okay, yeah, so for this one, we're given a bar graph which has all the populations of 20 different cities, and we want to find the total population. We're given the average. The average is along this dotted line. So actually all that matters is that, so when you have a set of numbers, the average is the total sum. So average equals total sum divided by number, the hash means number, so number of elements. So if you have a set, then if you want to find its average, you take the total sum and divide by the number of elements. Here we're given that the total sum, or we want to find the total sum, and we're given that the average is along this dotted line. And if you look closely, then they're split from 4,000 to 6,000 along 1, 2, 3, 4 intervals, which means each of them goes up by 500 because it'll go 4,000 to 4,500 to 5,000 to 5,500 and then to 6,000. And this dotted line is right in the middle of the first of the second and third markings, or the first and second markings. So 4,500 and 5,000. If you look closely, it's right in the middle of them, and so that means the value it represents is their average which is 4,500 plus 5,000 divided by 2, which is, let's just, okay, yeah, so it's, you can calculate it to be 4,750. So that's the average, which means that the total sum is 4,750 times the number of elements, which is the number of cities, which is 20. And now we just have to multiply this out. So this is 475 times 2 times 100, if we pull out the two tens, and 475 times 2, you can calculate it, it's 950. So 950 times 100 is 95,000. So that means the answer is D. So in this problem, the actual values of the bar graph were irrelevant. All that mattered is finding the average and then multiplying by the number of cities.
Can you explain the last step, Ram? There are a couple of questions like, where did you get the 100?
Oh, sure. So basically, we just need to multiply this 4,750 times 20 right here. I'm just making it easier to multiply that by pulling out the two tens. So it'd be 10 times 475 times 10 times 2. So you can group that as 100 times 2 times 475. 475 times 2 is 950. And then when you multiply the 100, you just have to add on the two zeros at the end. So it's just a trick to multiply them, essentially.
Great. I think we can move on because the recording will be available if anyone wants to listen to it again. It will be sent, I think, tomorrow or the day after.
Okay. Let's move on. Trisha?
Okay. So our problem says that suppose 15% of x is equal to 20% of y. What percent of x is y? So 15% of x can be written in decimal form as 0.15x, which is equal to 20% of y, which can be written as 0.20y. Now we want to find y in terms of x because we want to find what percentage of x is y. So like to eliminate these decimals, I'm just going to multiply each side by 100 and I'll get 15x equals 20y. And to further simplify this so that I'm not like working with like higher numbers, I'm just going to divide each side by 5 and I'll have 3x equals 4y. Now we want the percentage of x, like what percentage of x is y. So we're going to move this down into 3/4 x. So we're dividing each side by 4, which equals y. And 3/4 is just 75%, multiplying 3/4 by 100. So we get 75% of x equals y, which is answer choice C. Any questions on that one?
No, I think it's pretty straightforward.
Okay, that's good. Hari, you're back again?
Yep. So each of the 5 points A, B, C, D, E, F in the figure represents a different digit from 1 to 6. Each of the 5 lines shown passes through these points. The digits along each of the line are added to produce 5 sums for each line. So the total number, like the total of the 5 sums is 47. What is the digit represented by B? Okay. At first, looking at this question, it kind of seems difficult, but it's just a lot of steps. So let's do this. We know one sum is going to be A plus B plus C, right? Because it'd be this line. We know another sum is going to be B plus D, this line. We know another sum is going to be B plus F, right? This line. Another sum is going to be C plus D plus E to this line. The final sum is going to be A plus F plus E, which is this line. And they're telling us that all of this mess equals 47. So, to make it easier on us to do this calculation, what we can do is we can notice that there are 3 B's, and then there's 2 of every other letter. So there's 2 A's, 2 D's, 2 C's, 2 F's, 2 E's. So we can rewrite this to be 2 times A plus C plus D plus E plus F. And that all, you have to add 3 B's, right? That all equals 47. So, first of all, we learned in kindergarten that 47 is an odd number. And later on, you'll probably understand that in order to get an odd number, if you add an odd number and if you add an even number and another even number here, you cannot get an odd number. So we already know B cannot be even, because if it was even, we would not get an odd number. And if we don't get an odd number, the sum cannot be 47. That eliminates B and D. So now we can just plug in A, C, and E. If we plug in A, we get 2 plus 2 plus 3 plus 4 plus 5 plus 6. This is the tedious part. And all of this will equal 20. I know this because I've done this before, not because I'm super big brain. And that is 40 plus 3. That's 43. 43 is not equal to 47, so we can get rid of A. If we do this again with 3, we can do 2 times 1 plus 2 plus 4 plus 5 plus 6 plus the 3 times 3. Again, this entire thing is 2 times 18 plus 9, because that gives us 9. And that equals 36 plus 9, which is 45, which is so close to the answer that we want, but not our answer. At this point, if it was the actual test, you would circle E and move on. But for the sake of the solution, I will go to the next page and we'll do number 5. With 5, you do 2. So times 1 plus 2 plus 3 plus 4 plus 6 plus 3 times 5 equals, well, guess what? This all equals 2 times 16 plus 15, which equals 32 plus 15, and voila, we get 47, and we're done with this cumbersome work. I just wanted to note, for those of you that were like, how are you just saying A is 1 and C is 2 and all those numbers, right? it doesn't matter what we give A, B, A, C, D, E, and F. They just have to be all the other numbers other than whatever we chose for B. Because each one of these numbers is represents a different one of the numbers from 1 to 6. So that's why I was able to write it like that. Any question?
There is a common theme. Hari or anyone else on the panel could answer this. Is there any other way to do it? There were
This
some
question,
times n plus 1 by 2.
I could not find another way to do this problem. Maybe if another panelist found it, but
Yeah, Trisha, go ahead.
Yes, there is another way, which is a slightly less tedious than this one. Should I just work on that page?
Yeah,
I can erase it.
Okay. So basically, we have
Oh, you're erasing now. Are you on page 12, Trisha? On your screen?
Yeah,
Oh.
I am. So we have 2 A's. Wait 1 second. It's saying that. Okay. Give me 1 minute. Okay. So we have 2 A's. 3 B's. 3 B's, 2 C's, 2 D's, 2 E's, and 2 F's, right? So let's just take this as 2 B's and 1 B on the side. So we can write this with that, ignoring this 1 B, we can write this as 2A, 2 times the quantity A plus B plus C plus D plus E plus F. And we just add the B on the side. And this should equal 47. Now, like Hari said before, these numbers can be anything from 1 to 6. All we need to know is the sum of them, and the sum from 1 to 6 is just 6 times 7 divided by 2, which is the formula n times n plus 1 over 2 for the sum of n consecutive numbers starting from 1, and that is 21. So we have 2 times 21 here, plus b equals 47. And just moving it here, 42 plus b equals 47. And so then subtracting each side by 42, we get b equals 5.
That's great. Trisha, you may want to erase that 1 minus 6. Like, I think when you talked about 1 to 6, so if anybody looks at this page, it looks divided by 1 minus 6.
There you go. Is that better?
Yes. Thank you. Oh, can you explain the formula again for kids who don't know?
So the sum of n consecutive numbers starting from 1, so like 1 plus 2 plus 3 plus all the way to n is just n times n plus 1 over 2. So like the sum of 4 consecutive numbers. Here, 1 second. The sum of 4 consecutive numbers will be plugging in 4 to the equation. This is. Give me 1 second. My device is acting up. Well, I'll just verbally say it. Adding 4 consecutive numbers is like 4 times 4 plus 1 over 2. Let's see if it works now. No, it doesn't. 4 times 5 over 2, which is going to be 2 times 5 or 10. There is a proof to this, and you can just search it up. It's pretty simple. And yeah. Sorry, I'm having like technical issues with my device.
Okay, I think we'll move on. Are there any other questions on this?
No, we can move on.
We'll move on. Okay, that's good.
I can do the proof. It's not that difficult if you want. Basically, the whole idea is you're taking the, say 1 through 4, right? I can't write, sorry. 1 through 4. Oh. All you're going to do is take the first number and last number and add them together, so you get 5. And the middle numbers and add them together and you get 5. And you can, the whole understanding is, if you do that for if you make all of these 5, right? There's 4 numbers here and you only get 2 5s. But if you said this was 5, 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 you'd get 4 times. Sorry, I'm gonna, 1 second. Okay, let's just start all this over really quickly. 1 plus 2 plus 3 plus 4. What some people will do is they'll just rewrite it like this. And you know that if you take all of the numbers and you add them together twice, now you have the sum of the numbers twice, right? But really all you're going to do is 5 times 5, like 5, and add it 4 times. So that's just 4 times 5. So that's where the n and n plus 1 comes from. And the reason we have to divide by 2 is because we have 2 sets of the numbers, right? We have one set here and another set here. If we don't divide by 2, you're going to get twice the amount of what you should get. So the sum of the numbers is 10. Just fun fact, if you want to know.
Thank you. Let's go on to 17. Problems are going to get difficult now. So.
Yeah. All right. Okay. So the question is about factors of 2020 and some property of them. But before we even do that, let's figure out how to get the factors of 2020, because obviously you don't want to try a bunch of numbers. You want a systematic way to get them. So again, the idea behind this will be prime factorization. So the prime factorization of 2020 is 2 squared times 5 times 101. Okay. Now from this prime factorization, we can actually list down all the factors. So I'll do that right here. So 1, 2, 2 squared, 5, maybe I'll write like this, 5, 2 times 5, 2 squared times 5, 101, 2 times 101, 2 squared times 101, and sorry, 5 times 101, 2 times 5 times 101, and 2 squared times 5 times 101. So these are all the factors of 2020, just because any factor of 2020 will have to have just the primes 2, 5, and 101, and the exponents have to be less than or equal to what they are in 2020. So this is a table of all the factors of 2020. And the question is how many of these factors themselves have more than 3 factors? So the question now becomes, what numbers have more than 3 factors? So let's look at this. Let's see which numbers have 1 factor, which numbers have 2 factors, and which numbers have 3 factors. So it turns out that the only number with 1 factor is just 1. Pretty easy to see. 2 factors, it's only prime numbers. Because that's the definition of prime numbers. Only 1 in itself is a factor. All right, and 3 factors, it turns out it's only prime number squared. So I'll write that as p squared. The reason is that if a number has two prime factors, let's say 5 squared times 7, so there's at least two prime factors, then you have the four factors, which are 1, 5, 7, and 5 times 7. So if you ever have two prime factors, you already have at least four factors straight up. So you can only have one prime factor. And for example, if you have 5 cubed, then you have the factors 1, 5, 5 squared, and 5 cubed. So again, if the exponent of that prime now is 3 or more, then again, you have too many factors. So the only case left is prime number squared. So this means that the only numbers which are bad are 1, prime numbers, and prime numbers squared. So if I just circle all those numbers, I have 1. Here are my prime numbers, and here's my sole prime number squared. So these are the bad numbers, which means that the good numbers I have 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers which are good. So the answer is 7. Any questions about that?
Yeah. Very good solution.
Thank you.
I think there are many questions about prime factorization, how you do it. I think for those who don't know, it will be hard to go over for the sake of time.
I think this question is not really possible to solve unless you have experience with prime factorization. So that's why when I was presenting, I sort of just assumed that I just presented it to those who know prime factorization. And if not, then that's definitely a topic that you'll be learning. And that's why the AMC 8, it's up to 8th grade. So if you're in 3rd, 4th grade right now and you haven't learned it yet, then that's okay. Like this is an 8th grade contest. So that's fine. And eventually you'll learn it. And then you'll be able to solve this question.
Yeah, but that's a good trick to learn. Yeah.
Yeah. Okay.
Move on.
I think we should move on. Yeah.
Let's go.
Okay, so we've seen a pretty good mix of problems, but this problem proves to have rock solid geometry concepts. So this problem is rectangle ABCD is inscribed in a semicircle with diameter FE as shown in the figure. They are saying that DA is 16 and FD is equal to AE, which is equal to 9. The final question they are asking is, what is the area of rectangle ABCD? So I'm going to redraw our rectangle over here just so we can have a better look at it. So we have rectangle ABCD, and we know that this length is 16. In order to find the area of this rectangle, we need this length right here. Now, there are a few ways we could go about this problem, but I think the general approach we should take is we should start off by drawing a point here. We can call this point point G. Point G is the midpoint of line FE. Therefore, becoming a radius, if you can imagine a circle drawn fully like this, FG would be a radius of that circle. And FE is a diameter of that circle. So if we know the diameter of circle G, we can come up with the radius. And I will explain why we are coming up with the radius FG in a moment. So we have the diameter as 9 plus 16 plus 9, which is FE. So 9 plus 16 plus 9 is our diameter of our lovely circle G. And when we divide that by 2, we will get our radius. So 9 plus 16 plus 9 is 34. Divided by 2 is 17. So we now know that radius FG is 17. With this information, I'm going to draw point G over here, and we know that FG is 17. We can also say that CG is also 17. Why? Because if we look at this full circle here, CG is actually another radius of that circle. So we know that CG is 17. And if you look at this line that we've drawn, you can notice that it creates a right triangle. So I'm going to redraw this right triangle down here so we can get a better look at it. We have points D, G, and C. We know that this is a right angle since we know that this is a rectangle ABCD. This is a right angle. And we know that this length is 17. Notice that we are trying to find this length in order to complete the problem. Now, all we need to do is find DG. How can we find DG? Well, we know that FG is a radius, which is 17, and if we subtract 9, we can get the length of DG. So 17 minus 9 is 8, so we know that DG is 8. DG is 8 right here. So now all we have to do is solve for the last side of this right triangle, and then we've essentially solved the problem. So to solve for that last side, you can either use Pythagorean Theorem, which is a squared plus b squared equals c squared, or if you are more familiar with geometry, you might quickly pick up on the fact that this is a special right triangle, or an 8, 15, 17 right triangle. Either way you solve it, you will get 15 as the side length. So now, in our rectangle here, we now know that this side length is 15, and the problem is asking for the area of ABCD. So now that we have the length and the width of this rectangle, we can just multiply them together. And we should get, I'm sorry if that's cut off, we should get 240 after doing our calculations, which is answer choice A. Do we have any questions on that one?
I think there's a couple of questions about how did you get the 8?
Okay, so this 8, I'm going to just clear this diagram so it's more clear for you. This 8 is DG. So we have drawn point G in here, so this is the midpoint of FE. So we know that FG is 17 because we have calculated that is the radius of circle G, or it is half of the diameter of FE. So we know that since FE is 34, FG would be 17, since it would be half of 34. And then now that we know that FG is 17, we know that FD is 9. So 17 minus 9 is 8. That is how we get DG as 8. That was an excellent question.
Yeah, I think we need to move on.
Move on. Okay, problem 19. John?
Yeah, I'll take this one. So the question is, a number is called flippy if it alternates between two distinct digits. For example, 2020 and 37373 are flippy. So how many 5-digit flippy numbers are divisible by 15? So if a number is divisible by 15, then it's also divisible by 5. So divisible by 5. That means its last digit, its units digit, is 0 or 5. If its units, so we're given that the number is 5 digits. If the final digit was 5, then since the digits alternate, this would be 0 and this would also be 0. But a number can't start with 0. So that means it actually has to start with 5. So there's 5, and we have 5 because they alternate between the same numbers. So now let's say the remaining number is A. Then we're also given that it's also divisible by 3 because it's divisible by 15. And it's well known that the way to check if a number is divisible by 3 is if the sum of its digits is a multiple of 3. So the sum of the digits here is 5 plus A plus 5 plus A plus 5, which is 15 plus 2A. And this is a multiple of 3. Since 15 is a multiple of 3, this means that 2A is a multiple of 3. And in turn, this means that A is also a multiple of 3. Since A is a multiple of 3, that means the possibilities for A are 0, 3, 6, and 9, since it has to be one single digit, which means the numbers that work are 50505, 53535, and 59595, and there's 4 of them, which means the answer is B. So yeah, this problem requires knowing some number theory facts like the sum of the digits is a multiple of 3 if and only if the number is a multiple of 3, as well as the fact that if basically reducing from 15 plus 2a being a multiple of 3 to a being a multiple of 3. This is like a baby version of what's called modular arithmetic, but you don't actually need any of that here. You can just reason it this way. But yeah, so that's the problem.
Okay. 20.
Okay. So this is a pretty long question. A scientist walking through a forest recorded as integers the heights of 5 trees standing in a row. So we're given this like box of data, but it doesn't show them standing in a row, so I'm just going to write them standing in a row. So we just have 5 trees standing in a row. 1, 2, 3, 4, 5, just to help you visualize it. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost when rain fell on her notebook. Her notes are shown below, with blanks indicating the missing numbers. Based on her observations, the scientist was able to reconstruct the lost data. What was the average height in trees? What was the average height of the trees in meters? So we're given that tree 2 is 11 meters and that the 10th digit is 2 for the average height. So given that tree 2 is 11 meters and that the scientist recorded the tree's heights as integers, we know that tree 1 and tree 3 have to be 22 because when we divide, so each tree is either half as tall or twice as tall as the one to its right, right? So if the tree was if tree 2 was twice as tall as tree 1, then tree 1 would have to be 11 over 2, which is 5.5, which we know cannot work. And similarly with tree 3, if tree 3 was half as tall as tree 2, it would also be 5.5, which is not an integer. So we now know that tree 1 and tree 3 are both 22 meters. Now we can further find cases for the tree 4 and tree 5. So since tree 3 is 22 meters, tree 4 can either be 11 meters or 44, dividing 22 divided by 2 and then multiplying 22 by 2, so half as tall and twice as tall. Now we're going to look at the 11 meter tree. If tree 4 was 11 meters, then tree 5 can only be 22 based on the fact that we looked at tree 2, dividing it by 2 is not an integer. And now we're going to look at tree 4. If the tree was 44 meters tall, then tree 5 can be 22 meters tall or 88 meters tall, because 44 divided by 2 is 22, 44 times 2 is 88. So we have 3 cases for the trees, for tree 4 and tree 5. And we know that the average height ends in 0.2. So a really simple way is to just add all of the trees. It's kind of tedious, but just adding all the trees and taking the average of them. So this is just 22. I'm looking at the first case, where tree 4 and tree 5 are 11 and 22 meters. So this is going to be, I'm just adding them and hopefully I do the math right. And I get 88 for this sum, and dividing 88 by 5, I get 16, no wait, sorry, 17.6. And this does not end in 0.2. So we can say that this case, we can like say bye-bye to this case. Now we're gonna look at 44 and 22. So let's do 22 plus 11 plus 22 plus 44 plus 22. So adding this up, we get 33. I'm just adding these two, and then this two is 66 plus 22, which I get 99 plus 22, which is equivalent to 121. And then 121, I'm just moving this here, divided by 5 is 24.2. And we do get an answer, which is on, because this ends in 0.2, which is choice B. But just so that we make sure that maybe we're making some kind of mistake somewhere or another, I'm just going to add the last case and make sure that it's actually wrong and we don't get two different answers. So we have 22 plus 11 plus 22 plus 44 plus 88. And we get 33 plus 22, wait, sorry, 33 plus 66 plus 88, which is 99 plus 88, which is 187. And then bring this up here, 187 divided by 5 is 37.4. Sorry if that gets cut off, which does not end in 0.2. So we know that this case is not right. So we already know that the answer choice is B, and that's how you do this problem. There might be another way, but this is how I kind of solved it. Any questions on that?
There are a couple of good comments, very similar. Rather than adding up all the numbers, once you figured out the possible options, you could just add all the unit digits, right? And
That's
you know,
true.
for for the decimal to be 0.2, the unit digit has to be 1, right? 1 by 5 is 0.2.
Yeah.
So that's really a good trick if you want to just, if you're pressed on time.
Yeah, if you're crushed on time, then just go with that. It's much easier.
Yeah. Okay, and there have been many people asking like how long the webinar will go. We have 5 more questions. AMC 8 is 25 questions. I'm sorry, it's already we are more than an hour and a half into our solving. There are still, I'm glad to see 290 attendees are still on. So hopefully we'll wrap it up, and then we'll have at least a couple of minutes to talk about preparation, how the panelists did their preparation.
Harry, you want to take 21?
Yeah, 1 second. So 21. A game board consists of 64 red squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed on P. A step consists of moving the marker onto one adjoining white squares in the row above. How many 7-step paths are there from P to Q? So the way I did this problem was I started with some casework, right? I mean, just like going through it. How many ways can I get to this square? How many ways can I get to this square? Well, there's one way I can get to this square. And similarly, there's only going to be one way I can get to this square. Okay, then how many ways can I get to this square? Well, that's only one way. So there's one way to get to this square. And again, there's one way to get to this square. What about this square though? Well, there's one way and two ways. So there's two ways to get to this square. Okay, then how many ways are there to get to this square? There's one way to get to this square. And there'd be how many ways to get to this square? I promise I have a faster way, just we gotta do this way first. So there's one way here, one way here, and one way here. Therefore, there's three ways to get to this square. Similarly, there's one way, two ways, and three ways. But now, if we keep going like this, it's going to take us forever, and there's a really high chance that we're going to miss a way, right? So let's think lazy for a minute. What do we notice? 1 plus 1 equals 2. Oh, okay, that's cool. What about this? 1 plus 2 equals 3. Okay, that's right here too. 1 plus 2 equals 3, that works as well. Well, if that, and this pattern continues, right? This pattern should continue. There would be 4, would be 6, and there would be, if we imagine this was 0, there would be 3, then there would be 10, and 9, and then there would be 19. If this was 0, this would be 9, and then we would have 28 ways to get there. Noticing that pattern is crucial to solving this problem quickly. Because imagine doing this, right? One way, two ways, three ways, four ways. Imagine getting to 19 and having to do this 19 different ways. You're going to get lost so quickly. So knowing how to figure out the pattern is very important. And this addition movement to figuring out how many paths there are is a very common problem type in math counts. And the more you encounter it, the faster you'll see this type of pattern. Question?
That was pretty neat. I don't think there's any questions for this problem.
Cool.
What? Yeah.
All right. So let's do this question. So this question, basically you have a machine and you taken a number and it outputs depending on the parity of the number, it either halves it or does 3n plus 1. And the question is, how many ways, basically what numbers can reach 1 after 6 steps? So I'll do this on the next page just because there's not really much space on this page. So let me just, oops, my bad. Oh, okay, I see, cool, thank you. So the way I'll do this is the following. We'll work backwards from 1. Since we know that 1 is the final step, and we know there's 6 steps, it makes sense to work backwards. So if I have 1, then what can it come from? Well, I'm just gonna remove this because I think this is not the, like,
This is the, okay, yeah.
Yeah,
So
because
yeah, snippet. Okay, go ahead.
I'll just write it here. Like it goes to n over 2. Right. So if you have 1, then the point is that 1 cannot come from 3n plus 1 because anything of the form 3n plus 1. Let's just work this out right now. Is going to be of the form 3 times 2k plus 1 because it came from an odd number. So it's going to be of the form 6k plus 4. So only numbers of the form 6k plus 4 can ever come through this step, and any other number must come through this step. So that means that the only way 1 could have come was if it came from a 2. Okay, Now 2 is also not 6k plus 4, or as we call it 4 mod 6. So it must have also come from 4. Now 4 is of the form 6k plus 4, so there's 2 ways 4 could have come. It could have either come through 8, which is the normal way, or it could have come through this other method, and then that would be 1, because if you see 3n plus 1, 3n plus 1, 3 times 1 plus 1 is 4. And so far we've gone 3 steps back, so we still need to go 3 more steps back. So but it turns out we've already, so for this one branch we've already done all the work of backtracking, so we can just copy our work. And now for the 8, let's see what we get. So for 8, again, 8 is not of the form 6k plus 4, so it must have come from 16. 16 is, because 16 is 6 times 2 plus 4. So in fact, this must have come from either a 32, which is the normal way, or it could have come from 5. And 32 can only come from 64 because it's not of the form 6k plus 4. And 5 also is not of the form 6k plus 4, so it can only come from 10. So the numbers that it can come from is just 1, 8, 10, and 64 by this sort of working backwards tree. And that means that the answer is the sum of these numbers, 1 plus 8, maybe I'll do that in red again. 1 plus 8 plus 10 plus 64, which is equal to 83. So if we go back to page 3, that implies that the answer is E, 83. So maybe let's go back to page 4 because that's where the main work is. Any questions on this one? This is a bit tricky to like think about how to work backwards, but besides that, any other specific questions?
I think many people ask, how did you get 2k plus 1 and 6k plus 4? And the rest of the explanations, I think if they go back and watch the video, they can get it for the time.
Sure. So what I'm saying is that I'm trying to say that, okay, so if I have any number, I can always just multiply it by 2 to go backwards. That's always one way to go backwards. But it's possible that I might be able to go backwards through this step as well. But let's try to see which numbers can arise through this step. Well, n is going to be odd because that's what this says. So n is of the form 2k plus 1. So the only numbers that can appear are of this form, where k is an integer. And this is just, if you expand it out, you get 6k plus 4. So the only numbers that can appear through the second step are the form 6k plus 4. And let me highlight on this diagram where those numbers are. These are the only numbers of the form 6k plus 4. As you see, 4 is just 6 times 0 plus 4. 16 is 6 times 2 plus 4. And 4 again is 6 times 0 plus 4. Any other number cannot appear through this step. It must appear to just having. So let's, maybe as a more concrete example, let's try to like say, why can't we go backwards from 8 in a different way? So let's say we were to go backwards from 8 in a different way. Let's say we got x. Then we're saying that 3x plus 1 is equal to 8. So 3x is equal to 7, but this has no solution in integers. So there's no other way to go back from 8 besides just multiplying by 2. Does that clear up Or, yeah.
Yes, thank you. Good job. Let's move to the next one. We have only a couple more questions to finish.
3 more, yeah.
Okay, so this is problem number 23. As we are nearing the end, we're starting to see more complex concepts and longer problems come through. So let's take a look at this problem to really break it down. 5 different awards are to be given to 3 students. So we have 5 awards and 3 students. Each student will receive at least 1 award. In how many ways can the awards be distributed? There's a couple of things to keep in mind before we dive into this problem. The first thing is that there are only two scenarios when it comes to this problem. Either that one student receives 3 awards, one student receives 1 award, and the other student receives 1 award, or that one student receives 2 awards, another student receives 2 awards, and the last student receives 1 award. It's important to note that a student cannot receive 4 or 5 awards because that would leave 1 or more other students without a single award, therefore violating the conditions of this problem. So we have our 2 situations marked in green here. Now let's take a look at some concepts necessary for this problem. I'm sure that there are many different ways to solve this problem, but probably the most efficient way is to use the concept of combinations. So you should be really familiar with combinations, but if you need a refresher, I will run through it very quickly. So combinations are denoted as n choose k, and the formula for combinations is n factorial over k factorial multiplied by n minus k factorial. Factorials, as we've seen in different problems, are the number times all lower digits of itself. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1, but I'm sure we're familiar with that by now. So this is a handy formula we will need to use for combinations. Now let's dive into the 2 scenarios. So the first scenario denotes that one student receives 3 awards and the other 2 students receive 1 award each. So the very first thing we have to look at is, okay, we have 5 awards and one student is going to receive 3 of them, but the 5 awards are distinct. So which of the 3 awards is that student receiving? So in order to choose the 3 awards out of 5, we will do 5 choose 3. And this tells us, okay, we are choosing 3 awards out of 5 to give to the student. Next step, which student are we giving 3 awards to? So since there's 3 students, there's 3 different possible contenders for the 3 awards. So we are going to multiply 5 choose 3 by 3 because each of the 3 students are eligible to receive 3 awards. And finally, so now we've determined which of the 5 awards we are giving. Out of that 3, we are choosing to give to one of the students. Now, what about the other 2 students? Now, there are 2 awards left and 2 students left. So there are 2 different possibilities to distribute the last 2 awards to the last 2 students. So just as a reminder, this is read as 5 choose 3, and it's expanded into this equation here. Just for time's sake, I am not going to expand this equation right here, but when you do the math, you will end up with 60. So what is this number? Now we've ended up with a number. What is that? 60 is the number of combinations in which one student can receive 3 awards and the other 2 students can receive 1 award each. Now that we've broken down one of the scenarios, we still have one more scenario to go. I will do this in a different color. So now we have the scenario in which 2 students receive 2 awards each and the last student receives 1 award. So the very first step we need to take is saying, okay, we have 5 awards and student number 1 is getting 2 awards. Out of the 5 awards, which 2 awards are we going to pick? So we will start with 5 choose 2, saying we need to pick 2 awards out of these 5 to give to student number 1. And that is basically selecting the 2 awards. Next, we say, okay, now student number 2 also needs 2 awards, but we only have 3 awards left. It's important to note that we've already given student number 1 their 2 awards. There's only 3 awards left to choose from, and out of that, we are choosing 2 of these awards. So we are saying, okay, we have 3 awards left, and we're choosing 2 of them to give to student number 2. Now the final student, there's only 1 award left for that final student. So this is not necessary, but I'm just adding the 1 here. And there's one more condition that we need to put in here saying, okay, so we've seen that we've decided which awards we are giving, we are choosing. But now we also need to decide which students we are giving these awards to. In the previous example, in this scenario, right here, we saw that only one student was receiving those 3 awards, which is why we multiplied by 3, because there were 3 contenders. But now it gets a little bit more complicated because you are selecting 2 students out of 3 to receive the awards. So you need to do another combination of 3 choose 2. And this combination is to decide the students. So I'm going to just mark it here. These 2 combinations are for awards. And this combination is to decide which students are receiving the awards. Now there is a lot of math to break down here. And once you expand all of these using the combinations formula, you should get 90. So this is saying, okay, there are 90 different scenarios, 90 different possibilities in which 2 students can receive 2 awards each, and the final student will receive the final award. So now that we've created all the possible scenarios for these students to receive these awards, we're going to add it up so we can get the solution for our problem. So we have 60 plus 90 equals 150, which we can see is option choice B right here. So this was definitely a more complex problem that required some knowledge of combinations, and I'm sure there are other ways to solve it, but personally, this is the method that I found most straightforward and most efficient for solving this problem. Are there any questions?
Yes, I think there is one question on why you multiplied 5 combination 3 and then by 2, the first scenario.
That is an excellent question. So in this first scenario, just as a reminder, we have that one student is receiving 3 awards and the other 2 students are receiving 1 award each. So I'm just going to break down this first equation again. So we're doing 5 choose 3 because we're choosing 3 awards out of the 5 to receive. And then we're multiplying that by 3 because there are 3 contenders for those 3 awards. We're saying, okay, we need to select 1 person out of 3 to receive 3 awards. And then the question was, why are we multiplying by 2? The reason we are multiplying by 2 is because, okay, we said student A is receiving 3 awards. But what about students B and C? Students B and C are left and there are 2 awards left. So that is 2 more combinations. For example, student B can receive this award. So let me just write that down just to make it more clear. So we have student B and C, and let's say the awards are awards 4 and 5. So we have one scenario in which student B can receive award 4 and student C can receive award 5. And we have a second scenario in which student B can receive award 5 and student C can receive award 4. So that's why we're multiplying it by 2, because we have double the scenarios because of those 2 students and those 2 awards. I know that this concept is a little bit confusing, but I hope that cleared things up for you. That was a great question.
Right, last 2 questions. Thank you, Anishad.
I'll take this one. So what's going on here is we have a square with tiles on them, and their separation between them is D, and the side length of each one is S. We're given what percentage of the big square each of the total tiles take up, which is 64%. So what is the ratio D over S? So as you can see, there's D separation. We're going to calculate the side length of the big square, which is from here. My pencil is not working. 1 second. Just give me a sec. All right, yeah, sorry. So, okay. So if there's n tiles in the row, then there's going to be n of these tiles, each of which has side length s. So this is going to be, if we're trying to calculate this side length, let's call it x, then x equals n times s plus, and then the total number of separations is n plus 1. And the reason for that is that for each tile, actually, let me undo that. Anyways, for each tile, there's a separation right after it, but there's also one separation right before the first tile. So there's n plus 1 separations, and each of them has length d. So this is the total side length x. So the area of the entire square is x squared, which is ns plus n plus 1 d squared. And the total area of all the tiles, there's n squared tiles, and each of them has area x squared, so it's n squared x squared. And we're given n squared x squared over x squared equals 64 over 100, 64%. So I'm going to write this on the next page. What we have is n squared s squared over ns plus n plus 1d squared equals 64 over 100, which can be simplified to 16 over 25. So now, if you notice that the left-hand side is actually a perfect square. It's ns over ns plus n plus 1d, the quantity squared. This quantity squared is the left-hand side. So if we take the square root of both sides, we get this equals the square root of 16 over 25, which is 4 over 5. Now cross multiply, so you get 5ns equals 4 times ns plus 4 times n plus 1 times d. Subtract 4ns from both sides, you get ns equals 4 times n plus 1 times d. And this implies d over s equals n over 4 times n plus 1. Remember, we're looking to calculate what is the ratio d over s, and the value of n we're given is 24. N over 4 times n plus 1 is 24 over 4 times 25, which is 24 over 100, which is 6 over 25, and that is answer choice A.
I think we can move on, and the recording again will be sent to the emails of registrants or participants tomorrow, I believe. So if you want to review something, that would be a good time. We are already more than 2 hours into it, and we still have about 250 people sticking with us. So yay, last problem. Go for it.
Yes, yay, this is the last problem, and it looks kind of complicated at first, but then it's very, very simple, and that's the problems that I really like. So, we have rectangles R1 and R2, and squares S1, S2, and S3, shown below. And they combine to form a rectangle that is 3,322 units wide. So this length is 3,322, and it's 2,020 units high. So this length is 2,020. And they're asking the side length of S2. So, like, in this, the first thing that I would think of is trying to get in some kind of equation in a form where we can use S2 to get the side length of it. And one thing that I see is that the side length of S1 and the side length of S2 and the side length of S3, if we move this side length, or the side length of R2, if we move it up here, we basically get that S1 plus S2 plus S3 equals 3,322 because we're just moving this up again. Now we want to find the width in terms of S1, S2, and S3, and we'll see something really nice happen here. So we already have, sorry about that, we already have S3 here. So we have S3 here. And we want to write the height of R2 in terms of S1 and S2. So the height of R2 is just S1 minus S2 here, right? So we have S1 minus S2. So basically the width is just the height is just S1 minus S2 plus S3, which is equal to 2020. Now, when I did this, I was really, really stupid, and I just like did it a completely different way, and I added stuff, and I went like full out like try hard mode, and that was not what I saw, because basically you can just subtract these equations and you can get 2s2 because these two variables will cancel out, the side length of S3 will cancel out, and you just have S2 minus negative S2, which is going to be 2S2. And you get that is equivalent to 1,302. And so then you divide both sides by 2, and you get S2 is equivalent to 651, and that's what we wanted, and that is choice A.
Yeah. Any questions on this?
I don't see any question come through for this one. And A, we are done. And there have been a lot of thank you notes though. So panelists, you need to know, many people mentioned that, you guys have done an excellent job, very slow and very clear, and they've learned a lot. So I'm really happy. There were a few people, we still have about 230 plus attendees here. So really quickly, 1 or 2 sentences, panelists, can you please tell how you prepare, or what word of advice to your younger peers? Okay, you want to go in the same order? Hari, Anish, Paula. Just 1 or 2 sentences, because for East Coast people like us, it's almost bedtime.
Okay, yeah. Just a whole bunch of practice, like a lot of practice. So you're exposed to a lot of problem types. And then if you guys don't go as far as you wanted, all your hard work isn't being lost. I thought my hard work would be lost if I didn't go as far as I wanted, and that put a lot of pressure. But now as I'm going to higher math classes, that math sense and stuff helps a lot. So you're not going to lose any of your hard work.
Thank you. Gopal?
Yeah, I basically have the same sentiment as Hari, that if you want advice for doing well on these contexts, I think you just have to practice a lot, and at some point practicing itself becomes the journey rather than the actual end, whatever competition result. So like Hari mentioned, practicing a lot, and even if you don't get the desired result that you want, that work is not wasted, and you can use that intuition later on to be successful at other things that you do. So yeah, but the main thing is to work hard and practice a lot.
Thank you. Anusha?
Yeah, so definitely practice is the major key for this, because practice makes progress. So what I would recommend is, if generally for most math competitions, you can find previous papers online. So I would recommend going online, researching them, and solving old problems, just to get a sense of what you're getting into with the new test. And these concepts can be used in your school too. These problems can teach you a lot of new things, so you can apply these to your school curriculum. And yeah, it's really about thinking outside the box and using whatever knowledge you have to solve these problems.
Great. Ram?
Yeah, pretty much what everybody else said. Yeah, just practicing a bunch. Yeah, old papers are definitely a good way to practice. There's also books you can find that would help a lot with this kind of stuff. But yeah, definitely just working a lot before the actual contest would help to do better.
So it's the same theme over and over again, hard work and practice and persistence.
When you guys talk about practicing, can you tell me how many hours a day or how many hours a week you have to spend in it?
Trisha, you want to target that?
Well, I didn't really have a set time to practice when I did this. I just did them when like I wanted to, basically. And but like try to do at least a little math a day. It helps you, and basically also have fun when you're doing them, because if not, it's gonna be like another chore you have to do, and it's not gonna be different to you than school and everything. But like this, like math is gonna be so beautiful to you if you think of it as fun, and having fun when you do it. And yeah, practice is key also.
So
That is more important.
yeah, so resources, common theme is resources. So I'll just add one sentence about that. A very well-known resource is Auto Problem Solving website, AOPS. So you can just Google that, Art of Problem Solving, and you could find old AMC 8, AMC 10, AMC 12 questions with solutions there. It's a wonderful resource. And also taking part in competitions like NSF. So NSF registration will start in January. So even with the pandemic, I'm told we'll have the online exams. So just no matter how good or how confident you are or not, just take the exams, because it's, again, for fun. It is between you and math. It's not between you and anybody else. So just go for it and have fun, and keep doing it. It's up to you. It's all to you now, Daisy Uncle.
Thank you, everybody. You guys have been great. Really impressed and amazed. The spontaneity you guys are showing in answering questions. Thank you, Sri Priya, for arranging this and then making everything. And of course, we have to thank our silent partners, Rama and Gopalan. They have been behind the scene, running through the whole question bank and then answering and asking and everything. So we all we overshot our time limit, but still it's for a good cause, and people enjoyed it. It shows to me there are 200 people still waiting inside. So thank you, everybody. And then we will try to see whether we can repeat similar things in the future. And also, good luck to you. Like Sri Priya mentioned, the math contest, the NSF regional contest will start in January. Please register. It's going to be online this year, like we did last time. And so all of you should be able to participate and then gain. Winning is not the criteria here. Participating, enjoying, and learning is the whole criteria. Thank you, guys. And then we'll see you again the next time.